let's take a look at the product rule for taking derivatives. What the product rule says is that if f of x is equal to a function u of x times a function v of x, and if the derivative of u and the derivative of v both exist and make sense, then the derivative of f, the derivative of that product, will be v of x times the derivative of u of x plus u of x times the derivative of v of x. It's not just the derivative of each of the pieces. We have to break it up and do the derivatives of products with this rule. Think of this as the VOV rule. The letters in this rule almost spell out a word if you look at it and kind of squint at it. VU plus UV. So that's why I think of it as the VOV rule. Once you've written it out as VU, UV, you need to remember that a plus goes in between them. And then we put the derivatives on the second factors in each one of the terms. So now let's try an example. So here's that same function we looked at before. We need to find the derivative of f of x equals the quantity square root of x plus x squared times the quantity 5x cubed plus 2x. We've already identified what the two pieces of the products are. U of x is the first factor and v of x is the second factor. So in order to be able to apply our rule, we need to know not only u and v, but we also need to know the derivative of u and the derivative of v. Applying the power rule, it's pretty easy to see that the derivative of u is equal to 1/2 x to the minus 1/2 plus 2x, and that the derivative of v is 15x squared plus 2. Now all we need to do is put those into our product rule. So here we have our product rule, VU plus UV, our VOV, with the primes on each one of the second factors in each term. So now we'll go ahead and substitute u and v, u prime and v prime from above. So our v of x was just 5x cubed plus 2x. Derivative of u is 1/2 x to the minus half plus 2x. U of x is x to the 1/2 plus x squared, and v prime is 15x squared plus 2. It might be helpful sometimes to simplify this farther, but we've taken the derivative now. Anything we do after this is simply trying to combine some of these pieces together, and I'm not going to bother to do that here. But if you have to plug a number into one of these, sometimes it's a lot easier to plug a number into a derivative like this after you've combined and multiplied some of the terms.